We have to start from problems. What is the problems that we want to solve? Fundamentally, when we talk about healthcare, we want to solve three major problems in biomedical informatics, and AI is a subset of that. We want to look at triaging, diagnosis, treatment. If we optimize triaging, diagnosis, treatment, so you have a lot of improvement in healthcare. And to do that, there are requirements. Whatever solution you come up, doesn't matter what is the name of that technology. So you have to be accurate, you have to be consistent, you have to be fast, you have to be lean, you have to be robust. Most publication, most sources focus on one or two of these. This is one of the things that is rarely tested for academic research, that things do not fail. So when I call your software, it should respond. It should always respond. And if it cannot respond accurately, consistently, fast, and in a lean manner, and it fails, it has to fail gracefully.
The views and opinions expressed in this video are solely those of the interviewee and do not represent or reflect the views, policies, or positions of any organization, institution, or employer with which they're affiliated. The interviewee is speaking in their personal and professional capacity. Welcome, my digital pathology trailblazers. Today, I have an amazing guest, Hamid Tizhoosh. You probably have seen him on podcasts, on videos. Recently, Hamid, I came across your lecture from the API conference, Association for Pathology Informatics. This year, or I don't know, it was probably last year as well already, the foundation models were booming. And so I needed to learn more about this, and you had a fantastic presentation. Hamid is the professor of Biomedical Informatics at Mayo Clinic. Hamid, welcome to the show. I'm so happy to have you.
Thank you very much for having me.
It's not our first conversation, but I think it's the first time you're on my podcast, right?
Yes.
So I am super honored. And we always start with the guest. So let the digital pathology trailblazer know about you. Who are you and why you are so awesome to be on my podcast? Because you are.
That's a good question. Well, Hamid Tizhoosh here, faculty member, doing research. I did my education back in Germany and then stuck with medical imaging, radiation therapy, cancer-related stuff. Did move from Germany to Canada and then start working on analysis of radiology images for the first probably 15 years at the University of Waterloo. Before that,
Why did you switch to pathology?
I got sick and tired of black and white images. I want to see color. Color has meaning. Color is physical, has a connection to the creation of the universe, and color is beautiful. So,
see, whenever somebody is going to ask me, why is pathology better? I'm like, it's colorful. Why is colorful photography better? Why is a colorful TV better than black and white?
Well, also, that pathology is more definitive. It's more decisive. It's less subjective, supposed to be, because it's for many cases is the gold standard. So, and I wanted to be attached to that certainty.
Yeah, definitely, it's the basis for treatment. Whereas radiology exams, a lot of them lead to pathology exam. They're more like on the screening end of the spectrum. And so today I want to talk about the good, the bad, and the ugly of AI, including foundation models and all the new combination models, transformer models, and whatever is happening in the AI space or happened this year in 2024. And, your opinions on that. I want to go beyond what we're seeing in press releases, what we're seeing in publications. And my first question is, obviously, the adoption has not increased significantly since the beginning of the year. So I wanted to start with the key barriers to widespread adoption in the real world.
It's a very difficult question because you have to build a little bit to get to that point. We have to start from problems. What is the problems that we want to solve? And fundamentally, when we talk about healthcare, we want to solve three major problems in biomedical informatics, and AI is a subset of that. We want to look at triaging, diagnosis, treatment, and we want to respect to these three major ones, and you can find other things and add it. So, but if we optimize triaging, diagnosis, treatment, so you have a lot of improvement in the healthcare. So, and to do that, there are requirements. Whatever solution you come up, Doesn't matter what is the name of that technology. So you have to be accurate, you have to be consistent, you have to be fast, you have to be lean, you have to be robust. So 5 computer science information theoretical requirements that you have to fulfill. And just to allude to a little bit to what you said with respect to publication and delivering of promises, most publication, most works focus on 1 or 2 of these. There are not many works who try to access all of it. So accuracy, consistency, speed, being lean, not being memory hungry, and robust. So
So you guys have the 5 parameters in the business world. You're gonna have high quality and fast, or fast and cheap. But anyway, there is like the combination of 3. You never get 3. You have to pick 2.
yeah, I would say that's also industrial, because
Mm-hmm.
if you're accurate only occasionally, that doesn't help. So you have to be consistently accurate. You have to be fast, because we cannot wait days and hours for the response of the computer to come. You have to be lean. This is the single most neglected factor in academic research, especially from universities and research hospitals, that solutions are provided and they are extremely memory hungry.
So spoiler alert: the foundation models are not lean.
No, they are not lean, and that's one of the major problems, because they violate multiple principles, among other Occam's razor and the no free lunch theorem. So we may get to that, and they have to be robust. So they have to be what we call graceful degradation. So they have to be reliable. They cannot fail. So, and this is one of the things that is rarely tested for academic research, that things do not fail. So when I call your software, it should respond. It should always respond. And if it cannot respond accurately, consistently, fast, and in a lean manner, and it fails, it has to fail gracefully.
What does that mean, fail gracefully?
Imagine in the middle of the surgery,
Mm-hmm.
something happens. So it has to be something that we can manage and save
Okay.
the situation. It cannot just an airplane that crashes and then you cannot do anything about it. And when you go in individual examples, it becomes more and more clear. It's very important to keep this overall picture, the big picture, because when we go inside individual technologies for digital pathology, we may get lost in details.
Mhm. So, one question to this failing gracefully. So, for example, if an AI algorithm, let's say a specific one for showing malignancy in breast cancer, when there is like an error or something, instead of giving you a result, it would give an error message. Would that be a graceful failure, or how? Like, give me an example of a graceful failure of an AI algorithm used for diagnostics.
Let's not talk about really drastic cases like
Okay.
surgery,
Mm-hmm.
which should be obvious. Let's say less drastic. I'm doing information retrieval. I'm searching for similar patient, which is my field.
Mm-hmm. Mm-hmm.
And if I send the tissue image of my patient and say, do we have a similar case?
Mm-hmm.
Robust is you always come back and tell me something and say, I found these 3 patients that are similar to your patient, and you summarize it.
Mm-hmm.
If you cannot find something, you have to come back and let me know that I was not able to find something, and also tell me the reason. So we did recently and a study has been published in IEEE review of biomedical engineering, and we looked at all search engines. Some of them, they failed in 50% of the cases, which means you give an image, go find similar cases, they don't come back. They don't come back.
Oh, so we're just like waiting for nothing.
They crash. So
Okay.
it could be crashing for really simple reasons, but you don't come back. So that's being robust.
Okay, so this happens twice and you stop using the tool.
Yeah, so you cannot let the physicians having 20 patients or 20 cases to work on during the day. You cannot just let the physician hanging and say, what happened? So most of the time is being ignored. Now, the problems, triaging, diagnosis, treatment, requirements, accurate, consistency, speed, lean, and robust. How do we do that? The maxim is we have to use evidence. What is the evidence in medicine? Images, lab data, and historic data. Historic data is the manifestation, the quantification of experience. But if we ignore the historic data, which we don't want to do it, historic data is how the experience of really highly qualified, highly knowledgeable physicians, pathologists, have been recorded, and we are not using it at the moment. So if we ignore that, so images and lab data, blood,
Mm-hmm.
urine, molecular data, genetics, and all that. So that's evidence. If you want to develop a solution for diagnosis and it has to be accurate, consistent, fast, lean, robust, then you have to use evidence and you have to be able to provide evidence to back it up, whatever you say as a computer program. That's at the moment a major issue in AI, that we cannot back things up. There are solutions or the schemes of solutions, but we are not doing it per se.
What can't we back up? Like, give me an example. Easily understandable, can be from real life as well. Like, what would be not being able to back up something with evidence when you're developing AI on to solve a problem?
Well, if I go, our pathologist sitting in the building right beside me, if I go and ask them, and we have experts for all type of sites, and I asked our breast pathologist expert, what is this? And she tells me, this is papillary carcinoma. And then I ask why. She explains it. And as an engineer, I don't understand most of it, but she can explain it. So she can back it up. What is the
Okay.
backup here is her experience, is
Mhm.
her medical knowledge, anatomical knowledge, experience. When we talk about computers, computers have to back it up with something because computers are not physicians.
So does this tie into the concept of explainability of those models?
It's more than that. Yes,
Okay.
explainability, but it's more than that. Is the
Mhm.
precondition and the prerequisite that we can use all these things that, among others, with large language models are going on. If we cannot back it up, large language models will not make it to the practice of medicine.
Mhm.
And they have not made it to the practice of medicine as we speak right now. We use it for really very not
Consumer
critical.
type of
Yeah, so it's not
activities.
really, is not the bedside of the patient. So we are
Mhm.
not using it. So with these three things, so now we get into major problems of AI, and AI has put many things forward: foundation models, large language models, and so on. And we see a lot of problems. First of all, so start with the clinical side, and I'm going to say something sounds strange. The data is not available yet. I'm not aware of any major healthcare institution, at least in the United States, that the data is available. What does that mean? That means we have LIS, we have PACS, we have histopathology data, we have molecular data. They are not in one place in an organized way, in a tabular way, that we can go and look at the longitudinal data for a patient. They are not there.
Mhm. Mhm.
So the data that would be uh, necessary to do all those things that I mentioned is not available. So what
Okay.
are we doing right now in the AI
Yeah,
community?
what are we doing? Like, everybody's
I don't want to insult anybody, but we are playing in the
let's
sand.
talk in concept, but because I do want to touch on concepts, and whoever is studying the literature is doing it. But and that ties into the next concept, because all these things are known, but none of it is published. That ties into the next point I wanted to talk about, is that okay, these things are not rocket science. They may be new, but you mentioned like principles from computer science, from AI, that are known to people who are doing this. Is this being published? I assume not, because I would see those publications in my PubMed feed, which I've been doing for the last half a year, like weekly abstract reviews. There's nothing about any negative results. And that was my experience from, I don't know, over 10 years ago when I was doing my PhD. My PhD project yielded negative results. I was struggling so much to publish it. And, that's at the very basic level. It wasn't my fault that it was negative, but nobody wanted to talk about it because, like, who's going to read it? And yet, we do need to communicate it somehow. So, what are we doing?
AI research in healthcare has, and maybe beyond that, has four major issues right now, four major
Hmm.
challenges. And as you pointed out to that, so when we look at some of these challenges, and some of us look at cases and go into it, and you want to publish the weak points, there's not much willingness in the publication world to publish negative results, validation
Hmm.
reports. And it's very, very
Yes.
difficult when platforms publish results that on the surface appear breakthrough. And then all of us, we get excited, and when foundation models get published in histopathology, we work through weekends to see what can we get out of it. It's very serious business. We are at the institution that the maxim is the patient needs come first. So if there is something that can help us to do faster, better diagnosis, better treatment, we are very serious about it. We want to do it. So we take it seriously because it's published in very high impact, very high reputational places. And then we test it, and then it falls apart. And then we think others may be interested how we test it, because you have to confess we test really in a tough way. We don't really give any way for algorithms to escape. We say, okay, we take the toughest cases and say, okay, if I really bring it in a clinical setting and I have to use it this way, what happens? And then the last one that we did, foundation models for histopathology, average accuracy on TCGA was 44%. We did zero shot, which means we did not touch them. We did not fine tune them. And I'm sure everybody who publishes the foundation model said, no, you have to fine tune it. Well,
then that's a foundational model, right?
So, and if I want to fine tune it, then I have many other possibilities. Who says the fine tuned foundation model would be the best? I have to go and also fine tune many other smaller, leaner models that are more manageable. And we tested with a detailed subtyping, not tumor type, subtyping, much more difficult. We tested with highly imbalanced data, which is the practical, the clinical reality. So the 44% on average across foundation, and that's an interesting observation. Didn't matter which foundation model we tested, on average, we came to the same number, 44%, which is consistent with what we call in computer science no free lunch theorem. Which means there is no free lunch. So if you want to be better than others as an algorithm, you have to specialize. If you don't specialize, on average, you are the same level at everybody else. You will not be the best model. You will not be the best algorithm. So, which means no free lunch theorem in combination with Occam's razor, keep it small, keep it simple, would negate the concept of foundation model if they are really large. If they are really large and they cannot deliver. Maybe if we at some point have the multimodal heterogeneous data longitudinal for millions of patients, and then we do, maybe we break through that. At the moment, that's not the case. So if we look at this and say, okay, we cannot get there at the moment because on average we are the same, because we are working on general purpose histopathology foundation model. What does that mean? That means you are.
That is my question. I could not find it because what I was looking in the publications, I read like, what does this model actually do? We are used to the specialized one. Okay, it shows malignancy. It segments cells. It does that. I was looking for a list, a table. What are all the things that this model does? I could not find it in any of the publications.
You know, the fact if a model does not take any action or make any decision, that's fine. That's a different issue, because that means it is trying to understand the data, and then you can capitalize on that understanding for diagnostic purposes, for treatment purposes, for anything you want. That's not the problem, because they are usually trained in a self-supervised manner. We don't have annotated data. We come up with some made-up fake task for the network to understand the data, detached from any task, including diagnosis, treatment planning, survival prediction, anything like that.
But then I don't understand what they do. They go and understand data. What is the output of the model?
Okay, very simple thing. I take a tissue patch, a tile, not whole slide image, of course. I take a tissue patch and give it to the network, and then rotate it 90 degrees, give it to the network again, and say, look, this is the same. Of course, if you rotate the tissue image, for the pathologist the same, we realize nothing changes. For the computer, it will generate different numbers. So now we force the network to generate the same numbers if I have a tissue and I rotate it. So in order to do that, when we do it with millions and millions of tissue patches, the network will understand the texture, the pattern of the tissue. without knowing this is papillary carcinoma or this is
Mhm.
adenosis or this is adenocarcinoma. It doesn't know what that is. It just says, I see a pattern, and then you rotate it, and I figure out, oh, that's the same pattern.
Mhm.
That's the same pattern. That's all it figures out. But in order to figure that out, it has to understand the complexity of that pattern, which is the magnificent idea of self-supervision. Is one of the major things that the AI community has put forward. Amazing
Mhm.
that we don't need now annotated data. Without self-supervision, there would be no large language models, no foundation models, no nothing, regardless of their actual applicability and usability.
That is my next question, applicability and usability.
Yeah, well, usability, we get to the point that, okay, now you say it's general purpose. That means for the entire histopathology. So it understands brain and prostate and kidney and breast and everything. It understands. So that, to begin with, goes against what we are doing in pathology, because in pathology, everybody is specialized. Again, no
Well, in the
pre.
US, because it's actually either US and Canada or one of the only countries where you have such a very super specific narrow specialization of pathology. In all the other countries, uh, you're a pathologist.
Look here, we get last number I have, we get 55,000 consult cases
Mhm.
across US and internationally coming to the
And
Department of
I'm not saying that this is not how it should be, because the nuances of the disciplines basically caused the high specialization in the US and wider second consults, and why you consult a specialist. And I just wanted to and you know that it's not the case in other countries.
Let's take breast cancer. So
Hmm.
80% of them are lobular or ductal carcinoma. Most pathologists with a little bit of training can look at it and say that's ductal, that's lobular. If you look at the remaining 20%, the remaining 20% are highly rare complex cases. For that 20%, you need highly specialized breast pathologists. And that's why
Hmm.
we have consult. That's why the 80% can relatively easily be diagnosed in most hospitals across the planet. But then for the 20%, you need specialists.
So where do you use AI as leverage? Where does it make sense?
General purpose means you want to do those easy cases. So you want to do only ductal and lobular. And that's why it falls apart when we tested with detailed subtyping of TCGA data, that you go beyond the tumor type and you go in detailed subtyping, which is much more valuable and useful for treatment planning. Then it falls
Mhm.
apart, because of course it cannot do it, because it is general purpose. So then you have to do something. You have to fine tune it. You have to train another class. Oh, okay. I thought foundation model will solve all my problems. No. So it's a philosophy now that we say the major issues with AI. So I'm departing a little bit, deviating a little bit from the big picture, but fundamentally, one thing is that you cannot build on general purpose AI for medicine. That's at the
Mhm.
moment, based on everything I have seen, that's my way of thinking. That if you want to bring AI to the bedside of patients, we have to specialize. So
Okay.
that means you have to have a model for breast, one for brain, one for prostate. Researchers won't like it, because if I have a general purpose model,
That's true.
5,000 people will download my model. So, but
Yeah.
if I work on prostate, probably only 200 will download.
So, Hamid, when you say, oh, the general will do the easy cases, for me, when you say that, I'm like, okay, then it's not a help for a pathologist, because pathologists can do it without clicking a mouse.
It could be, Alex, because imagine, so in developing countries, if you talk about countries that have no pathologists, uh,
Yes, that's what I'm saying. It's not going to be a help for a pathologist. It's going to be a help for a healthcare professional that needs to then figure out how to get that to a pathologist. And then the next pathologist is going to have to figure out, okay, do I need a specialist or can I deal with it? So it's like that would be the of triage application of this for non-pathologist healthcare systems
but
or
but this is what
healthcare.
confusing, you know. So I
Mhm.
I I I have I've been trying it trying to figure it out for myself as an individual researcher. So
Me too.
we throw all that data on a gigantic model and then train it with a lot of carbon footprint, and then we want to solve the easy problems. So I thought AI want to help us to solve difficult problems. So that's one issue. Going back to the big picture, so the major issues with AI at the moment, AI, taking any model, especially foundation models, large language models, they are not addressing those five: accurate, consistent, fast, lean, robust. They are not doing that. So you can list many problems that they are deviating. They try barely to address one of them, or maybe one and a half, or maybe two, but never five. So we can, and long as we don't have those five, we cannot get to the bedside of the patient. That's one problem. Foundation models, large AI models are failing. Nobody likes to hear that. I don't like to hear that. I have made my
No,
career.
I was hoping they're gonna succeed
Yeah,
and they're gonna solve our lives.
I want to stay enthusiastic, and we will stay enthusiastic, but that doesn't mean we have to be blind.
Yeah.
So we have to.
You know what? That's a tough balance, I have to say, because
I know.
I am always super enthusiastic about all those new technologies, and then I'm like you say, you said, oh, where are the validation reports? I'm like, that's what's needed to take it anywhere close to the patient, because that's going to be the first thing you need to do in any lab under any type of regulatory constraints. And I mean, then it's just like talking about technology, which is nice, but the question is, when is it gonna be applicable?
If the first problem is that you are not addressing those five conditions, because the second problem is the data is not available yet, and it sounds very strange, because most hospitals are that have large amount of data, we are migrating, combining them in the same place. Most of the time is cloud. That creates a lot of delay. So we have to solve that problem. That problem is outside of AI community, that the data is not available. AI researchers can complain about it. I have been complaining about it. The data is not available. If you give me better data, more data,
Gonna do a better job.
data, we will do a fantastic job. So we will see how it plays. Most likely the next 2 years, we will close those gaps, and then data is unified somewhere that you can operate on it, and then we will see what we can do with it. The third problem, the third major issue with AI is this out of control enthusiasm for large language models. Why I'm saying that? I use large language models all the time.
I use them all the time too.
Editing for this, for summarization, I do that all the time. So I'm talking about medicine. Language is not evidence. We said evidence is imaging, is lab data, and maybe historic data. Language is not evidence. Language is subject to variability and subjectivity. We cannot build the future of medicine based on language. That's a fundamental problem.
So, question here. Let's take an example of language used in medicine would be a pathology report. Do you say this is not objective because the evaluation of the data that is subjective is objective? Sorry, the other way around. The objective data, the image, is the image. It's going to always be like that. But then you have an interpretation by a pathologist, and we all know that if we get 0.7 concordance, we're fantastic, which means 30% at least we're not that fantastic. So then it gets translated into subjective language, which is the report. Is that what you're referring to, or am I misunderstanding?
No, just go from the other side. Look at it.
Okay.
There will be no pathology report or radiology report without the tissue, without the picture. So the pathologist is looking at something, using her brain with entire medical knowledge in there, summarizing it in some words, which is subject to variability. So if you want to really capitalize on the information and knowledge in that report, you have to bridge it back to the evidence, which is the image, which is RNA sequencing, which is X-ray image, which is blood data, whatever the data is that was involved in that. I'll give you an example from dermatology. We were looking at skin cancer. We wanted to look at highly differentiated, poorly differentiated type of cutaneous squamous cell carcinoma. And after a while, we realize, oh, the tissue image is not the only source of information that dermatologists get. So what else he or she getting? They look, among others, at the medical photo that is taken from the lesion on the skin
Mm-hmm.
prior to the biopsy. This is a lot of information. You are not giving me that information. How do you expect me
It's
that
the same for like gross images from.
whatever comes in that report is the result of several other modality and the general medical knowledge in the head of the pathologist? So that that report in itself, you cannot detach it and then work with that data and get, you can get some statistics, you can do some
Understand.
experiments,
Mm-hmm.
but based on that, I cannot come up with next generation diagnostic treatment survival type of thing,
Mm-hmm.
unless again the bridge to the evidence is restored such that we know this is the variability, this is the evidence, and so on.
Question, because
Sure.
that's something you were talking a lot about in the talk. I'm going to link to the talk from the API. Was the retrieval augmented generation? How does that play into the explainability, into incorporating text, into the multimodality? Because when I learned about RAG, I'm like, where is it? Why can't we use it? It's like points you to where the information is from. And I thought that's going to be the next super hype. Never happened. Didn't happen in 2024 yet.
You just read my mind, because
No, I just listened to your talk.
that the two problems that we talked, let's skip the data is not available.
Mm-hmm.
This is
Mm-hmm.
not our fault as AI researcher. This is the
Mm-hmm.
fault of life, hospitals, lack of money, heterogeneity of archives, landscape of corporations, many, many reasons. So the first problem was we are not accurate, we are not fast, we are not lean, we are not robust. The second problem was
We're
language
so
is,
bad.
yeah, we are so bad. So, and language is not evidence. What is evidence? Imaging lab data, which means you have to go multimodal.
Mm-hmm.
So at the moment, there is not a single truly multimodal system that has been trained with high quality clinical data and has been validated at multiple sites. There is no such a. Most likely we will do it in the next, when I say we, I mean the research community at large. Most likely we will do it in the next 2-3 years when
Okay.
that data is available. I,
Mm-hmm.
I mean, yes, I can go and get 50,000 cases and then get a little bit of the X-ray, a little bit of reports, a little bit of demographic, and do something. This is all sandbox playing experimentation, which is necessary. We are warming up,
Mm-hmm.
but I'm talking about serious research that leads to products that can be really
Yes.
used in the practice. There is no such. So
I'm
we
gonna
need
quote
multiple.
this one: serious research that leads to products. Because life is like a funnel. You're gonna have so many publications, and then only it's like drug development. I work in drug development. You have so many candidates. One is making it into the no, five are into the clinical trials. One is actually making it to the shelves of the pharmacy. So serious research that leads to products. Let's
So
continue.
the multimodality, which is evidence, brings in the necessary information and knowledge to compensate for lack of accuracy, consistency, reliability. But then speed and being lean has to be engineeringly managed. That's a design question, and the robust. So the first two, accuracy and consistency, is a matter of evidence. So we have to bring in multimodality to, if you look at, let's say, breast cancer, so you need the X-ray images, you need the MRI images, you probably have ultrasound, you have the tissue sample, you have the patient demographic, you have some genetic information. All that goes into a system. Then you connect it to a large language model, and now we get to the magical word that you mentioned, RAG.
Rag.
So now, if you do even multimodal large language models or language vision models, still you cannot deploy to the bedside,
Mm-hmm.
because one key word is the explainability, which is another word for it is source attribution, backing it up.
Yes.
So how do you back it up? Because again, you can give 10 million patients to the large language models that do multimodal, understands X-ray, understands tissue, all that. But then I ask, how do you know that? You have to back it up. You have to
Mm-hmm.
tell me why you are
Okay,
saying.
because I saw this kind of image in radiology, then
Now,
hyper eosinophilic part of the tumor in whatever. Okay, so basically, like as if a pathologist would tell you, why do you diagnose this as squamous cell carcinoma? Because I see this, and these are the attributes of a squamous cell carcinoma.
But we trust the human being because according to the Turing, we still have nothing but the human expert to judge the performance of the AI. We don't have anything better. It's the human expert, the pathologist in our case, who tells us right, wrong, correct, incorrect. So the retrieval augmented generation is now what we are seeing and is emerging very slowly is a renaissance of information retrieval. Information retrieval in medicine was very limited and is still limited to just searching text. You type text or you select some boxes and you search in an archive. We cannot search for X-ray images. We cannot search for tissue images. We cannot search for RNA sequencing. We cannot search for social determinants in combination with this and so on. So we do not have a multimodal information retrieval system. Now we are in a pickle. Now we are in a very, very tough spot because we know that large language models with all their capabilities cannot be used unless we go multimodal. And then we have to back it up with evidence. And the evidence has to be outside of the AI, which is very interesting. AI can be backed up and explained with an information outside of the AI, not the information that AI has digested. So because that information that is digested goes into the black box, we don't have access to it, we don't understand it, we cannot justify it. So we need an outside archive of knowledge, reliable knowledge, which is high quality clinical data. Hopefully heterogeneous, hopefully free from bias. Which bias will be there, we have to deal with. So now, if we want to do that, do we have multimodal information retrieval system? No, we don't.
No. But now it makes sense to me why you might need a general foundation model, because if it understands stuff in the image, then that's going to be the deliverable from the model, showing me where whichever information is without telling me what to do with this information.
Absolutely. So
now I start understanding.
At the moment, so 1.5 years ago, we had the possibility to start doing a foundational training, a foundation model, and I realized without retrieval, we cannot really check it. So we stopped. We stopped and we worked on developing a platform for information retrieval. We're still working on it. And now we are truly multimodal. For breast, we have 6-7 different modalities, for example. And we realize, oh, we cannot be general purpose. You have to specialize. If you really want to solve the tough problem, you have to specialize. It's a very painful decision to specialize. Because again, if I have a general purpose model, 10,000 people will download it. If I have one for prostate, probably only 200 will download it. It will affect my life as a researcher. So that's a problem. That's a limitation that we have to deal with. But again, the patient needs come first. It's not about me. It's about how can we bring AI to the bedside of the patient in a reliable manner. Now, this emerging renaissance of information retrieval is everywhere. It's not just in large language models. It's also in the so-called agentic AI. So AI based on agents. So
yes, the agentic, yes.
Which is a field I'm not working on, but the core of that is also not possible without retrieval.
Because basically you have the orchestration of data retrieval from different places, which I'm of course super excited about, and I'm like waiting for this to be available, and I'm like, where is it? How long will I have to wait?
So not only we find out, so we don't have multimodal information retrieval. We needed to be able to deploy large language models and foundation models. But we also find out that AI cannot be used in a reliable way unless it is connected to good old-fashioned information retrieval. Why is that? So that should make us think about what does that say about the state of artificial intelligence in general, that AI needs outside help. So now this brings us to the biggest headache I have right now. just as a researcher thinking about things, that is because we departed from historic origins of AI when we introduced transformers.
Yes. Well, I didn't know that, but that
Transform,
was the breakthrough. Mm-hmm.
it was, well, it is the breakthrough, but
Yeah.
it deviates and goes in a different direction from the initial ambitions of AI. What was the initial ambitions of AI? Was to mimic the human brain, the way that
Mm-hmm.
human brain works. And the breakthrough came when we look at the cat vision and convolutional neural network came, even Boltzmann machines, restricted Boltzmann machines, autoencoders, all of that you see still the traces of that initial ambition that we want to imitate human brain. And we said, look, do not extract attributes and features from the data like we did prior to 2000. Give the raw data to the network. The network will figure it out. The network will extract features. Do not do manual design. Before 2000, what we would do before deep learning,
Yeah,
we
it
would
was all
sit down and
handcrafted features, defining
handcraft.
thresholds, defining what you wanna analyze, basically.
And AI community was telling everybody, among others myself as a young researcher, that you cannot do that. Because when you manually design things, your subjectivity is in it, your knowledge is limited, whatever you do will be limited, you cannot understand the data in its entirety. Tissue is a very complex type of data. Okay, then we said, don't do it. Manual design is not good. Give enough data, AI will figure it out. Then by 2017, we deviated from this in a historic departure from the initial ambitions of artificial intelligence. We introduced transformers. Transformers are highly manually designed,
Mm-hmm.
and there is nothing in them. You can say, okay, this and this, but there's nothing in transformers that you say, oh, this is like human brain. Well, transformers are fundamentally exhaustive correlation analysis. I look at the relationship between words and between image parts and then figure out this is important, this word is important, this part of the
Mm-hmm.
image is important. We call it attention. There are this, I think, and I'm sure many colleagues disagree with me, I think that attention is a misnomer. It's a
Mm-hmm.
correlation. It's not attention. It's not
Okay.
the attention that we have in our visual perception. It's not that attention. But if you read the seminal paper of 2017 on transformer, there is no reference, there is no ambition in there that transformer want to imitate human brain. They want to understand language. That's a
Mm-hmm.
machine to understand human language. That's a correlation analysis machine. Fantastic. We are using it. But that deviated from the initial historic road toward imitating human brain. And it's now getting even worse. Mamba is another technology that is supposed to be much better and is better, is faster, is lean compared to transformers. We have to see how it performs for some big
Mm-hmm.
cases. We will see. But still the same thing. People sit down, very smart people, very knowledgeable computer scientists, they sit down and manually design a solution. This is contradictory to what the AI community was telling everybody 20 years ago.
Mm-hmm.
So that's a historic problem for AI community, which means at some point, transformers, Mamba, or anything else will collapse. They will find a niche to operate on for not very sensitive applications, most likely. And then new topologies, new architectures, new type of networks have to come if we want to continue maintain the ambition that we want to mimic the human brain, because this is not the human brain that somebody said this is a state here and then I selectively select this state and then this is the correlation. This is manual design. We scorned that, we rejected that, we negated that 20 years ago.
Okay, so that brings me to, like, when you look at the classification of AI, and everybody who does not know about this is afraid of AI taking over. You just said why it's not going to take over. And you just said, okay, this is why we're still in the narrow AI. So the narrow general and the whatever that is, theory of mind, or like the super AI, why we are still operating and conceptually are stuck in the narrow AI bracket, so to say.
If I sum it all of this up, you can see it, and we saw it in our latest validation. AI, when I say AI, whatever is there, large language model, foundation model, they have hit a ceiling in their performance. They cannot go beyond this. Now, if we go multimodal, we will push this ceiling a little bit higher. Definitely. And it will be better. We will use it for many cases. There is no question about that. But that's a problem why we have hit this ceiling cap. We cannot go beyond this. And we see it in all possible ways. We saw it for search and retrieval, that the foundation models trained with hundreds of millions of tissue patches could not figure things out unless they need additional fine-tuning. So, okay, so again, we are violating multiple computer science information theoretical principles. Does that mean, what does that mean? Well, nothing. It's very good that we have large language models, we have foundation models. We have to just be clear what they are good for.
Yes.
And where are we right now? We are in research, we are in clinical deployment. This is good for triaging, less sensitive. Maybe we can triage a lot
and
better.
I think people are afraid of stating that, because then, like, you're so much more honest if you can say this is for this purpose, not for something else.
Yeah, and people don't, that's the issue again with the specialization. Also is applicable to the AI researchers. Senior researchers, most of the time they have already specialized. So younger researchers, they try to stay as general as possible. They need the publication. They need to advance in the academic ranks. So, but if you specialize, you will go in detail. For example, I give you a very simple example. There is a misconception for image retrieval. If I give you a tissue and you go and search, most people who are not in the field, they think that's a very easy task. Even the fun to understand the complexity of search and retrieval, they think if we can push the whole slide image into one vector, there is a established field that is called vector search. Any document, any modality, any data that you can represent with a set of numbers that we call a vector, it can be searched. Yes, but searching for tissue is a very complex, is a problem that, again, in computer science, we call it NP hard, which is a fancy word for impossible.
Okay.
It's a fancy word. So it's NP hard, so non-polynomially hard. So it's like if you have lost your cell phone, how difficult it is to find your cell phone. Have you lost it in this room? That's easy. Have you lost it in this city? That's a bit more difficult. If you have lost it in Milky Way galaxy, that's NP hard. How do I search in Milky Way galaxy if I'm using general purpose? I want to understand all the cell nuclei shapes and connective tissue for any body part. If I just look at the skin, I get scared with the diversity of anatomical diversity of the skin. And you want to address everything? You cannot address everything. Maybe we can in 50 years. I don't know. At the moment, we can. At the moment, we have to specialize. So put things in place. We know what we have, what problems they have, what they are good for, but we have not been able to deliver for clinical utility. That bothers me. Part of it is egoistic, is the ego of academician. I want to contribute, and it's for me as a computer scientist is more pressing to contribute to the patient well-being, because I don't even have direct connection to the patient. I don't see the patient. I'm trying to help the pathologist. The pathologist and oncologist will help the patient. So it's for me more pressing to deliver something that the pathologist can really use. And when I see our pathologists, how knowledgeable they are, how good they are, how fast they work. I've been shadowing our pathologists, well, how they work. Oh my God, they are good, they are fast. If AI wants to beat pathologists, which will not happen in the foreseeable future, even after I retire, I don't think so. So they are good, they are really good. They understand anatomic pathology, they understand the diseases, they are good, they are responsible. It's very tough to beat them with some computerized method. So we have to be serious about this. So give you another rather marginal, which is important, example. The factor that we use to measure the first one, accuracy. If you choose area under the curve, that's useless.
That's in every paper.
That's useless. When we look, if we want to test the accuracy as a Turing test, we have to use macro average of a font score, and you are lucky if you get to 60% at the moment.
Mm-hmm.
You can't get to 60%. The data is imbalanced. And then we trick it and say, oh, okay, so let me get weighted one. And then I push it up. I get to 82%, I can publish.
It's a science, like how to pick the right test so that your results are in the 90%. And you can do it.
Now, the problem is, so academic honesty and integrity is an ongoing issue for all of us. And there are two things that we something is academically dishonest. One is that you manufacture data, maybe by selection, not actively, or you omit something. So, for example, if I have a method that is not consistent and I only provide the accuracy, but I don't say that it's inconsistent, I'm omitting a fact. If I don't say that my method takes 2 hours instead of 20 seconds, that's omitting a fact. That's academic dishonesty. You cannot deliver product for healthcare if you do research like that. So that's something for all of us. And especially with AI, such a sensitive emerging technology, makes it even more pressing that we have to be serious about these metrics and the way that we do things.
So yeah, dishonesty, let me tell you, when I realized how easy it is, like how much easier it is to be dishonest than honest, when there is no guarantee that you're going to have result from your research. It's a funny system because, like I told you, I tried to publish my results from my PhD, and the moment I realized, oh, I could have fantastic results, was when I was pipetting my PCR stuff, and I'm like, how about I pipette my positive control into where my bands should be? Of course, I didn't do it, and then it was difficult for me to publish. But I didn't do it because I thought, okay, if I actually did it, how much more difficult it would be for me to later like confirm these results. But it's not something that people don't do, because how many of those high impact factor Nature publications from, I don't know, 10 years ago, 20 years ago have been disproven? It's a concern. And do you have thoughts on how to prevent it other than appeal to people's honesty?
Well, that's a problem for all of us. Basically, in academia, we are living under this Damocles sword of publish or perish. And publication is everything. So publication is the way to promotion, to higher salary, to fame, which is most likely the most appealing aspect of it for the ego of academicians and researchers.
It sure is not the money, that I know.
Well, no, it's not the money, but again, so it's a self-realization that drives many of us into research, to take your ideas and create it. But the system is such, the peer review system is working. Science is a self-regulating system. Long term, it works and things get filtered out. But short term, we suffer from a lot of imperfections in the peer review, which is us, which we are writers, authors, and reviewers at the same time. And that drive, that push, corrupt us in one way or another at some points to different degrees. And we may just be a little bit more lenient to do this and that, to just get things published because we have to publish. And that's where, again, omitting something or not reporting this and that becomes really something that you can push your papers forward. Of course, nowadays you have to do more. You have to have really large number of data. You have to have beautiful, appealing visuals and diagrams and images. That is associated with quality. It's very difficult right now to have, again, expert reviews. I don't know, when I see journals that are publishing medical pathology related stuff, and it's a very niche field and everybody knows everybody, and I ask around, did you receive this paper for review? Nobody has reviewed that paper. So who is reviewing those papers? It seems when I send stuff and I don't like Alex to read my paper, so I just exclude Alex or the journals. The worst thing for journals and publishers are when they are on paid positions.
Uh-huh.
Um, when professors become editor in chief, your entire academic reputation is tied into quality and integrity of the publication. But when you are on a paid position, that's a different story. I cannot judge what does that mean exactly, but that becomes more of a business than a academic undertaking. Then I see many journals that, and that's another point of the corruption. I'm using the word corruption in a loosely way, so
Mm-hmm.
not people freak out, and not being fully integrated within the academic honesty for all of us, for administrator, for researchers, for professors, for publishers, all of us. I'm not taking myself out. It applies to all of us. And you see, one of the recent trends is that you send papers, and then within 24 hours, the editor rejects to review your paper. He or she rejects to send it out. And of course, there's a lot of institutional favoritism, a lot of bias there. That's where all of us, we have been sleeping and we don't talk about diversity when it comes to that. So, a very small number of institutions are the ones who are publishing most in high impact places.
Mm-hmm.
One might say, wow, because they have a lot of talent, and there is no doubt that some institutions may have more talent than others. But there is also no doubt that there is institutional bias among publishers. And then if a paper comes from University X in a developing country, there's much more likely to just not even get reviewed compared to a highly reputational research institution
Mm-hmm.
or university from Europe or from US. So we can't do much about it. All of us suffer from this, and all of us we do it. And that's also driving us to violate academic honesty, because we want to be part of that big league.
Mm-hmm.
And so that's when I see, oh, I'm coming from an institution that is basically an underdog. I
Mm-hmm.
cannot publish as easily as this and that. So we are going through a huge transition with AI and digital pathology. I want to be part of it. So that makes us here and there just to close our eyes and say, okay, that's okay. So let's do
Mm-hmm.
this. Let's go this way, which is also contributing to that many papers are being published in AI, in medicine, and in pathology that don't amount to anything. So you look at it on the surface, it's fantastic paper, and then you go into it, you see it has left and right problems, is not really solving any issue,
Okay.
and that's why we don't have enough innovation. At the moment, we have become simply users of the technologies that are mainly being put forward by big corporations. So from
Mm-hmm.
transformers to TensorFlow to everything else, all pieces of technology. We are not innovating anymore in academia or researchers. So there are exceptions here and there. It started with innovation at academia with Jeff Hinton and Benju and LeCun and everybody, but then it migrated to the bigger corporations because they have more resources, they have more easily access to talent and all that. It's a point of concern because when we become users only, then okay, so we will be depending on those corporations. I'm not saying it's something bad, but I'm just worried that innovative power is getting concentrated in just one place.
Mm-hmm.
That's the
So
issue.
most of the people are gonna be users, and like part of this exercise is okay. We want those people who are not um, uh, contributing to the innovation, to the development, to actually benefit from the technology. And on one hand, I'm thinking, okay, if a big corporation gets this technology, they have a better chance to actually bring it to the bench, bringing it to the patient, or bringing it to, in the normal life, to consumers. And but that's like a catch 22
That's
again.
correct. That's right. And I have done a lot of work with companies, small ones, medium ones, relatively big ones.
Do you have any companies? Do you have any spin-offs
No,
of your
I
things?
don't have any. So since 4 years, I don't have even any industrial contact. So my hospital is much more sensitive to that. So
Mm-hmm.
I'm not doing any consulting, nothing at the moment.
Okay.
Since 4 years, it's in one aspect is emancipating, but in some other aspect is restrictive. So you have to
It's
just
a
find
choice you
out.
make. You either, you know,
It is,
it's a choice you make.
and companies are actually less prone to corruption because they are driven by profit and they have to deliver. They
Mm-hmm.
can, I had a case back. We got back to the authors of a paper and said, "What is about this and this?" And they said, "Oh, we have moved on. We don't work on that paper on that subject anymore.
Okay.
You published it barely a year ago. Why you are not working on it again?" A company can not say that easily. They have to stick. They have to provide service. They have to make sure that their products are safe. We are less subject to responsibility for what we publish. We publish and go.
Mm-hmm.
And if you ask me about the paper that I published 5 years ago, I don't know. We
Yeah,
just
it's
published.
like a project-based work. You work on a project, you have a certain, amount of money, a grant to put towards it, and then you move on. Um,
And this has nothing to do with AI
mhm,
and pathology, but is now being magnified. Again, we are
mhm,
going through the historic transition, and it's multiple things: post-pandemic effects, digitization of pathology, AI. So at least three major events are intersecting, and then we are in the middle of it, and everybody wants to contribute, which is fantastic, which is great. But then I always get scared. You see people that have barely started working in less than 2 3 years, and people call them expert. Okay, well, I don't even know we
yeah,
have such
it's
a thing as expert in some fields of AI. Foundation models were invented barely 2 3 years ago. Who is an expert in foundation model?
mhm.
I don't think so. So that's worrisome that we take these words loosely and then.
I know where it comes from because it's so cutting edge that the moment you learn about it enough to be able to explain what it is about more or less to somebody else, they consider you an expert because it's new. Nobody knows, especially people who are not in the field, who are not working on it. And to me, this expert or this type of expertise is too much attributed to people who are talking about it because it's just recently developed. On the other hand, I am a proponent of people having a working, especially in digital pathology and an interdisciplinary field, of everybody in the team having a working knowledge of the other contributors. And I believe this is important because if I have a working knowledge of, like the basic concepts of computer vision, what is segmentation, what is classification, all these things, I know how to apply it to my area of expertise and who to go to ask for this application. And that counts for IT, for computer scientists, for quality assurance, for everybody who's involved in this group. And I think within the group, there is kind of an understanding. Okay, this is a working knowledge. But if you speak about it, like if you speak to people about pathology and they wouldn't know your background, would somebody say you are a pathologist? They would, right?
Well,
Because
I had to correct Google. Google had listed
see,
me under say and above my picture would write pathologist, and I had to contact them with a lot of trouble and say, "Look, I'm a computer scientist. I'm not a pathologist."
exactly. But yet you have so much more knowledge of pathology than anybody else outside of the digital pathology circle. And I know this happened to Anant Madabushi as well, that I didn't know if he was a pathologist or not before I talked to him on the podcast. So I think that's part um, of this, well, confusion. But what you're referring to is like the cutting edge thing that people just barely started developing. So not even the developers are experts in this technology.
There is one thing that is there is very encouraging, very good, and at the same time is very dangerous, and that's the decentralized approach to AI,
Mm-hmm.
democratization of AI, so to speak. Everybody is doing AI. You can just go and download some code and some data and use some available GPU power publicly and do it as a student, as a
Mm-hmm.
trainee. Many hospitals are following this scheme that physicians hire some postdoc and then they start doing AI. So a decentralized approach to AI, not that the hospital says if you want to do AI, you have to go to this section, this department, and you have to talk to them. No, let everybody do it. Great, fantastic. That's because a big part of the technology has been made accessible. The inventors did not file patent, and the corporations have sort of graciously made it available. The problem is this: the decentralized approach within the society, within academic institution, and within hospitals, which is important to us, works only for very small projects.
Mm-hmm.
If we want to change the face of medicine, if you want to do big things, if you want to bring impactful projects that change the way the clinical workflow is established, you cannot do decentralized. You have to find people. For the decentralized approach, you can get an intern who acquainted with AI 5 months ago. People are young, they are smart, they figure it out, everything is public, there are good YouTube videos, there are tutorials, there are Coursera, there is this and that. They figured out, they do it. If you want to do a whole big project, is a big project does not only contain AI that you grab a very smart young soul and say he or she will do it. It contains a lot more. So that's where you need expertise, you need track record, and so on. So that's something. Actually, again, the corporations do a better job than
Okay.
hospitals and universities. They,
Mm-hmm.
when it comes to really sensitive things, they emphasize and magnify track record and competency and push the decentralized approach aside. No, no, no. We have to focus. We have to bring competency. We have to do this and that. So that's a point of concern that people have to distinguish. So if every pathologist does AI, that's fantastic, but that's for small projects.
Mm-hmm.
If you want to do big projects, really bring products and services that will affect all of us, you cannot do that. You have to select some people, put them in place, give them resources, and then they can do it because they have all the required competency and knowledge for that project.
So, question here, what do you think about deployment of innovation? Because what I'm frustrated with is how difficult it is to propagate this change. The example I give is, okay, if there is a company or healthcare system or whatever, like institution that grew by acquisition, you can pick like a site, you can pick a player, you can pick one location that's gonna test, implement, and then you can maybe deploy and iterate fast. What about if it's something that's centralized? Like, I'm frustrated. So we started talking about the retriever augmented generation, and you said that there is this renaissance of the retrieval of information. How difficult it is to implement it? I don't see it being implemented.
No, because again, two things. So the data is not available in the
Hmm.
silos of hospitals and healthcare providers. They don't have their ducks in a row.
Okay.
Nobody does, to my knowledge.
Hmm.
Nobody has the entirety of recent data, not even historic data. Let's say the past 5 years, all
Okay.
of it available somewhere centrally accessible, such that you can, because you cannot bring the computational power to the data. You
Hmm.
have to bring the computational power to the data, but the computational power, the GPU and cloud is already there. So you have to bring the data to the computation. That's why
Okay.
at the moment is going very slow because we are doing the opposite.
Hmm.
The wisdom was always you cannot shuffle the data around. You have to bring the computer to the data. But now we realize my data is an LIS and PACS and this and that. I have to bring it to the cloud. I have to
Okay.
bring it to the GPU power. That's what has slowed everybody down in terms of real big impactful project. I'm not talking about, again, sandbox
Hmm.
projects that we do and I take 10,000, 50,000, 100,000, even a million cases and I do this and that. So the data is not available. And even if it was available within the silos of hospitals, still nationally or even globally, we do not have that available that information retrieval will change everything, not just for us in the United States, but also across the globe if it is diverse. So if I can tap into the African, the European, the Chinese databases, or they contribute to a center that is copied across
So,
Europe and Africa and so on. So as long as that doesn't happen, which is a matter for the next decade, we will not do big things.
So, what is your thought on the decentralized approaches, the ones federated learning and all the cousins, where the concept is to actually bring the computer to the data? Would it be possible at the moment? Would it be possible just like even for one institution? And would this be helpful for RAG, or do we need repositories?
I put a lot of hope into that, and back then we worked on it. We haven't not published. We have a major one with proxy federated learning. We published recently with in collaboration with multiple other research groups. Uh, the problem is, and we hoped that that will remove a lot of
Mm-hmm.
problems with patient privacy. I don't want to share the data and so on. But
Mm-hmm.
it seems hospitals are not interested in that. So
Okay.
that's my sense. When I go and across the nation and talk to everybody, hospitals are not really interested in doing that. So one pretext is that, well, we have to put a lot of infrastructure in place to be able to do that, because you
Mm-hmm.
still have, you need secure buffer to make the connections and so on. Doesn't matter what technology you use, all different types of federated learning. But I think the hesitancy is more that at the moment the hospitals, the CEOs and uh, managers and people in charge of the finances have not figured out yet what will happen with the value of the data,
Mm-hmm.
one thing, and what will happen with the traceability of patient information, even if it is embedded within. I think the first one is more important for most hospitals, to be honest.
Yeah.
So they know that's gold, and they just don't want to share their gold yet. And nobody would confess that they would say, no, 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 this is not the point. The point is patient privacy. We don't know, and then we
Yeah.
need infrastructure. But it's also, this is an El Dorado. This is the largest El Dorado at the beginning of 21st century. You
Mm-hmm.
don't want to lose that. You want to make sure that
No.
you capitalize on the data.
Definitely. So, speaking of that, like you mentioned diversity. So, if we had repositories, if we had databases from different places, we would get access to diverse data that then would translate into better performance of the algorithms, better performance of the models. Let's talk about the bias in the data that's going into training those models, because we just said, or you just said, that okay, most publications are published from a highly respected institutions, which happen to be big institutions with a lot of patients, but these are only the patients from this institution. So thoughts on that? How, what does it mean, like how bad it is that it's biased? Because I have like mixed feelings about it. First, okay, if you want to have this as a general, and that ties into what we said, because if you want it to be generalizable, if you only have a biased data set, it's not generalizable. But do you need to have it generalizable? Then just say it's for this particular data set. Is that a problem?
It would be a problem in many cases because that would create disparity in healthcare delivery. So that if
But we already have that.
we have it, but we don't want to
We
encourage
don't
it.
want to propagate it and
If
encourage it. Mm-hmm.
if the government does its job, the administration does its job, it should not encourage it, that we create more disparity now that we have a cutting edge technology.
Mm-hmm.
I put the ideological political side of it aside, so that I don't want to deal with that as a scientist.
Mm-hmm.
But we need diversity, the biological diversity, anatomical diversity. We need that. We need to be able. And the point is, if I get 10 hospitals to work with each other, the general bias will be reduced, of course, but the bias that we may be socially interested in politically, which is, well, let's say, societal bias, racial bias, and so on, which has been prevalent in the society, that will still be in the data. AI may be racist because the data that comes is racist. And the data that comes is racist because we are racist. So there is no way around it. We cannot wash ourselves and say, no, 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 I'm not racist. Everybody else is racist. So
Yeah.
this is now a problem, and too much to ask from the AI community to take care of a human society problem.
Mm-hmm.
Racism, discrimination is a real problem that some groups for some diseases, if you take, for example, about prostate and Caucasian versus African Americans, we have disparity historically speaking, and in clinical trials, in drug development, all that. So
Mm-hmm.
as AI community, we cannot compensate for centuries of discrimination and racism that is prevalent in the human society. We can point to it, we can try to do something, but nobody has the moral high ground. So we cannot be better than the human society. AI cannot be better than human society.
Mm-hmm.
AI will be as good as or as bad as human society.
So, question here. Let's say we have the solutions for big institutions, specific, societal demographic profile, but we don't want to use it and label it that it's just for them because we propagate disparity in access to care. But then we deprive them from something that they maybe would benefit from. So it's another side of the coin. Like you cannot win.
Yeah, that's why most likely again foundation models are not a good solution because they
Mm-hmm.
are big, they are clumsy, they need resources, and the mass of healthcare providers, clinics, small clinics, community hospitals, all them will be most likely excluded. They
Mm-hmm.
do not have the resources of big hospitals. They cannot license big technology. They don't have the team to maintain it, and so on and so on. So we need more pervasive type of technology. We need commercialization of technology such that companies, in order to make sales, make things cheaper. We cannot do it. As a researcher, I cannot do it. I can put my code on GitHub and say, okay, if you want to play with it, download
Go
it. But
ahead.
that will not solve the problems that we have
Mm-hmm.
in medicine. At the end of the day, somebody has to make it a commercial grade solution, device, software, and then driven by the free market economy, be forced to provide high quality at low price, the way that
Mm-hmm.
has worked out for the past millennia anyway. So I'm not worried about that side. It will happen. It will happen,
It
but
has already happened for so
it
many
has
things,
happened,
right?
not at the level that we expect. So
Mm-hmm.
AI has, or we have as AI researchers, as AI users, we have promised a lot. We have not delivered much. So that's a little bit worrisome. That we are maybe are here at the top, and then we have to come down and approach the axis of reality at some point, hopefully within the next 2 years, without creating the third or fourth AI winter. I don't know. So hopefully not. Hopefully not.
Hopefully not. So I see one thing that you said, it has to go into devices. So, like, we have apps on the phone. They have to be lean, they have to be fast. Putting stuff in medical devices, like all those algorithms, and that needs to be super nimble. And the other thing that I've seen, like a parallel discussion or still going on, is okay, the underserved institutions, underserved areas, underserved countries, they do not have access to whole slide imaging technology. And for a long time, this was like, oh, then we're excluding them from contributing. Now, what I'm seeing, the stuff, the work, the AI work, image analysis work that was done on whole slide images, this can be deployed on static images. So it kind of went, okay, it was developed by those who had resources. It was developed on a technology that may not be deployable, scalable for places, institutions without resources. But because of this work, now you can actually use it on static images, and taking static images can be done in any place where you have a microscope and a camera, microscope and a phone even.
Many hospitals get second opinion requests, and usually right now the glass slides are being packed and seriously on the
Mm-hmm.
trains and cars and airplanes that send really physically for second opinion. Many hospitals, larger ones, are thinking when when those glass slides arrive for consultation, they digitize them and then they distribute them
Mm-hmm.
across the hospital for second opinion. It's conceivable that at some point we will have digitization centers or regional ones that you can just send it there and they digitize and submit it for you.
Mm-hmm.
So that could be a new branch of technology and business.
And there are already, um, obviously a lot of people are thinking about it, but I know a couple of initiatives. One of them is the Digital Diagnostics Foundation started by Matt Levitt. I don't know if you've heard of them. They are starting like central histology labs where basically institutions without the access to digitization, even to pathology, histopathology labs, they can send things there and then have it distributed. But that was a question when I was asking myself, okay, if I had a procedure done, something like my tissue would be taken out, and I would like to have my digital slides. At the moment, the way to request it is I need to get my glass slides, and I have a microscope, so that's fine. And I'm a pathologist; I can look at it. I have pathologist friends who I can consult. But for a person who is outside of the medical field, this is useless. Like, but in radiology, you get a CD or whatever. The CD is already outdated, but you get your images. This is part of the package of your data, and that ties into data discussion that we had before. You get the report, but report is interpretation. If you wanna, as a patient, like be in charge of your treatment, or like, I don't know, request a second opinion on your own, the way to get this is like impossible for pathology.
It has to be, if you want to do it really fast, it has to be some sort of web service, secured web
Mm-hmm.
service that you upload your whole slide image or even patches, selected patches. There are many research groups, pathologists share information on social media, and they usually just uh, upload a mosaic of multiple patches at different
Diagnostic
patients. They say,
patches,
what
yeah.
do you think? So
Mm-hmm.
that has what the practice has shown when pathologists want to consult each other. And the easiest way, the fastest way, the more accessible way would be to let pathologists anywhere on the planet to upload those patches. Most likely, we will not do WSI uploading because it's not necessary.
It's not
You look
necessary,
at
no.
it,
Mm-hmm.
you look at it, and you say, "This region, I don't know what that is." So you don't need the entire whole slide image,
Mm-hmm.
which could be most of it could be, I don't know, just fat, and you don't.
But
You
not only for consultation, also for patient records. Like you get your labs from any checkup, you get your images from the radiology exam. Why would you not get the patches from a pathology exam?
Yeah. So we can deploy technologies that you download and you have on your desktop and you can use it lightweight. But this type of technologies, the conversational AI, the large language models, retrieval, augmented, they have to be centralized.
Mm-hmm.
So that database, that knowledge base should be somewhere that is easily accessible, manageable, maintainable, and so on. I don't see any way around it. So the future is those disruptive, revolutionary changes in medicine in general and histopathology in particular have to be cloud based. They are somewhere, and then you access them. So instead of just sending it, you just log in. Maybe just for
Mm-hmm.
specific hospitals, if they are specialized, you just log in into the hospital's platform and say upload your images and request a second opinion. That
Mm-hmm.
would be one model. Of course, in a perfect world, we don't want to do that. We don't want to do every hospital does that, and
We
of course,
have it right now with like all the electronic health record systems, and we still do fax. That is like
yeah.
the cutest thing ever.
Yeah, but that would create also additional disparities among which hospitals, the ones that at the moment they have a lot of data, they will be the gigantic monsters and they will dominate
Mm-hmm.
everybody. That's not good either. So we want everybody to
How do you so
contribute.
in the future, how or like the nearest future, like what do you see to empower the small institutions? So one end of the spectrum is okay, the big institutions have resources, but they move slow. The other end of the spectrum, and that has been like that's life in smaller institution, you can iterate faster, so you can actually deploy stuff and that's more cutting edge in a smaller institution. You know, you're going to have everything in between. What do you see is going to drive the adoption in the nearest future
Well, the smallest
in
one, everybody else, they have the data is gold because
Mhm.
small hospitals and clinics, clearly you cannot play in the major AI league because it's difficult for you to attract AI talent. So bigger hospitals will do that. They grab everybody and say, okay, you come to me. I give you the possibility to do your research. But the smaller clinics, the main point for them is their data. if they
Hmm.
have highly specialized data, if they have specific type of population
Yes.
demographic. So that's gold. If they organize their data and make it in a way that whenever it is possible and safe from patient privacy, they can make it accessible. That would be a
And
participation
capitalize
in
on that.
source of revenue. Yes, they can.
I
It
don't
will
think
come.
I don't think there is awareness of that. That just organizing your highly specialized, even if it's just a specific demographic data in a way that you can say to the world, hey, you want to include this population, here is how you can do it, and here's how you can help our patients as well, and this is how we're going to capitalize on that. So that's a super important point.
Well,
And
things will change again. So,
mhm,
like the fascination of large language model, we are hitting the cap, we are hitting the ceiling. We know that's not reliable. We know that we cannot use it for clinical utility. Is loose, is in the air, is too subjective, is too flimsy. You cannot do that. So we need to connect it to evidence.
mhm,
There's no way. We have to connect it to evidence. But the evidence is not available, is not organized, is not retrievable. That's something that we are just closing our eyes at the moment. For researchers, it's easy. You find something, you do some experiment, you publish papers. That's great. But for hospitals, for healthcare providers, for people who really have the possibility, for policymakers, for administration, so we have to look into that. And some initiative has to come from the government to
mhm.
make enable some hospitals to gather and join forces, maybe create a national initiative
Okay.
to create a source of the. If US does it, everybody else will follow, definitely. So a national archive of histopathology data, let's say. So we are still looking unimodality as from the perspective, the biased perspective of histopathology. But then most likely we have to bring radiology and other lab data and patient demographic and social determinants and all that. We have to bring all of it in one place. This is something that is very unlikely that happens without any framework from supported by the government, by the
Mhm.
taxpayer, basically.
So, question: why did TCGA not become that thing? Why didn't it grow? Like it has 40,000 cases, 40,000 different cases with different modalities, but that's it.
One thing, the software was not there, the technology was
Hmm.
not there yet. Most likely, I don't know. I don't remember. I have read a lot about TCGA, but I don't know. And many people that I know have been involved at the beginning
Hmm.
of formation of TCGA. I wasn't even involved in histopathology when it was
Oh,
formed,
really?
and
Yeah, I mean,
so
for me, it has been there forever as well.
it's a big question. It's a big question. Most likely, software was not there, AI was not there, digitization was not cheap and accessible as it is today.
Hmm.
All those factors, but it was not created with the vision of making it a organized, indexed, searchable, easily accessible archive. Still is you have to painfully search and find something and then
Hmm.
just download it, but you cannot really perform anything on that the data
Okay.
itself, which is a static archive. It's not a dynamic archive. We need dynamic archive that the computational power is right there. Maybe this is the main thing that is missing at the TCGA. Maybe TCGA 2.0 should be on a cloud with GPU power right beside it. You may
Hmm.
want to pay for it to use it, but you can do it if you have to.
So another thing that I'm seeing, so there are like two extremes. When I get my PubMed alerts about digital pathology and AI every week, there are two extremes. One extreme is what we were talking about, are the foundation models and the like heavy computation, transformer-based stuff. The other thing is smaller journals and more like groups that I have not heard about, different countries, publishing papers about, oh, this group, this pathology group used this particular algorithm, and like stuff that's kind of basic, but I see it coming up. Like for example, oh, they did Chi-67, they did their internal validation, and now they are okay with using AI. The same for PDL1, ERPR, like uh, things that have been there since the beginning of pathology image analysis. I see kind of like a resurgence of this, and to me it means, okay, the there is increased adoption, not only by the major players. It's a good sign to me. It's not like, the cutting edge stuff, but I'm thinking, okay, we're actually moving forward with the things that can be applicable. And a hurdle there is, okay, when you are in your workflow as a pathologist and you want to use them, they have to be easily accessible. Currently, software issues like, oh, you have to change the software, then it disrupts your workflow, even if it's a digital workflow. But I see it as a good sign. What good signs do you see with leveraging what we already have? Because we have a lot, and the deployment is, very punctual, but I see it happening, and I'm positive when I see it. Specifically when, like, you read the paper and it's not rocket science, but I always feel like it's heartwarming to me when I see, oh, this pathology group tried this software. Oh, and they bought it from this company that has it as a product. And they decided, okay, it's good. They did enough validation to actually use it for patient decision making or decision support. What are your thoughts on that?
So definitely the decentralized approach, which is also
Hmm.
pervasive within the society and research community, has contributed to that. And it's very encouraging. I love it. That is not like that anymore. That only five researchers at five major hospitals are the ones who are setting the tone. That would be the end of research. Everybody is contributing now, which is great. This is the way that science works. And then, yes, at the beginning, maybe people would just read Hamid because Hamid is coming from a major institution. But after 2, 3 years, they realize, oh, a small university from a remote village in Japan has a fantastic idea. So that's the way that science has worked in the past 300 years after the Enlightenment. So it's very encouraging. I love it. Things are happening. Again, a lot of unchecked, unverified, sketchy results from everybody, not just from a small one, from medium one, from big one. Everybody is doing that. But that's fine. Things will get filtered out, and then we will get the pieces of gold remaining in our seed. That's fine. So this will go ahead, and a lot of good things are happening at a very small scale. We
Hmm.
are, as we speak, we are using large language models. Our physicians are using it just to summarize reports. So a new patient comes, has 40 pages of report. Either you have to read it, you can dump it into a large language model. Can you summarize it, or you can ask questions? Not much risk, but again, so you have to find bits and pieces of technology that is safe at this level, and we can use it. So it's not clinical utility. It's
Hmm.
very remotely assistive to the physician to do her job. A lot of that will happen. A lot of small pieces of technology are getting integrated at a small scale, but very large number of people are doing that. That's great. We need to, but the thing is, and maybe that's my problem. I think I keep thinking at the big picture, and I say, how can we change medicine? And that's not going to happen with decentralized AI. That's not going
Hmm.
to decentralized AI research. That's not going to happen. We need concerted, joint, organized effort supported by big money. So multiple hospitals, ideally multiple countries, initiate it, and then you can start working something. I see some attempts in Europe. Europeans are sometimes faster than others, not always, but sometimes. Americans are usually behind, but then when they get started, they can just
Then they go
they
fast and.
they go really fast because the resources are there. Hopefully, next 2 years is the time that something like that should happen. Creating large initiatives, and then those small contributions, also all of them will start flowing toward that funnel and a bundle to be much more effective than individually, which it takes a long time to be appreciated and used.
Mhm. Do you think anything of this can be driven by a patient in any way, in any shape or form? Like, I'm thinking about the digitization of pathology images. Like, could this be driven by the patients, by them requesting that their tissue images are digitized? Or what are your thoughts on that?
Could be patient advocacy groups could play a
Mm-hmm.
role, definitely, but that would be at the level of policy making,
Mm-hmm.
allocating resources, impacting the agenda of leaderships of hospitals and granting agencies. At those levels, yes. So, but not directly for us
Mm-hmm.
as pathologists and researchers. Not for us.
Mm-hmm.
I don't see it that directly how it can happen. But patient advocacy groups, absolutely, they are stakeholders in the entire picture, and they can push things forward.
Mm-hmm. Anything that you can share about what you're working on right now? You mentioned the image search and the retrieval. Anything that you can reveal?
Yeah. So again, I gave up the idea of a foundation model alone.
Mm-hmm.
So at the
Oh,
moment,
really?
we said, okay, we will specialize.
Mm-hmm.
That big picture that we said, we have conversational AI, but you have also information retrieval, you have multimodality, so three big components. We are doing it for just for breast cancer. So
Okay.
this was a very painful decision to reduce your ambition and say, okay, we will not do it for histopathology. We will do it for histopathology of one case, let's say breast cancer. And then we had to go deep into it. We had to figure out the triaging challenges, the diagnostic challenges, the treatment planning challenges, and every case is different. And then we are putting it together. So we are trying to create. I'm still working on what I call the Mayo Atlas in my
Mm-hmm.
own environment, which is that collection of technologies, multimodal conversational AI connected to information retrieval. So that's a the word atlas is loaded. It has been in use for almost more than a century, to my knowledge. But it doesn't matter what we call it. So is it intelligent next generation information system, whatever that is? People want to throw in always the word AI to make it more sounds more important. But information retrieval is a very powerful technology that we have not exploited for medicine yet.
Mm-hmm.
At no hospital, we can search for RNA sequencing, we can search for radiology images, we can search for histopathology. We can only search by typing some text, which is very
Mm-hmm.
limited. It cannot give us anything. And and that's why when you see the RAG concepts being used, the large language models, they, for example, they connect to Wikipedia. They use
Mm-hmm.
Wikipedia as source or
Okay.
journal. And then if you say who said that, and then they give you a link,
Mm-hmm. Mm-hmm. Mm-hmm.
that won't work for us in medicine. We need high quality clinical data,
Mm-hmm.
verified, free from variability, that we
Mm-hmm.
can use as a base, as a solid foundation to fact check
Mm-hmm.
any prediction, not just by AI, anybody else, any trajectory, any probabilistic statement that comes from AI or any other technology has to be fact checked by evidence. And when we say evidence-based medicine, which is again connected and is sometimes is exactly the same thing as individualized medicine, none of that works without relying on historic data. And historic data at the moment is under digital dust. We are not using it because it's not accessible. After you upload your whole slide images, you are not using it anymore. It's just there, and you just pay
That's
for the
true.
storage.
I'm keeping fingers crossed for Mayo to be the pioneer of the way of structuring data in an institution that can be then modeled so that we can actually capitalize on the
We have to be
multimodal
patient.
data that.
We have to
Mm-hmm.
be patient. So I
Yes.
understand that young colleagues may not be able to exercise patience, but if you want to go long, you have to go slow. So and that's very painful to go slow. I'm
Mm-hmm.
learning that in the past 3 years. I didn't think there are still things that I can learn in terms of being patient, but it's a whole different level of patience if you want to make sure that it's reliable, the quality is there, and it's beneficial to the patients.
Mm-hmm. Thank you so much. And I hope to see you again online, offline at the conference. And we will definitely talk again here on the podcast.
Thank you for the opportunity. Thank you.
Thank you so much for listening. It means you are a true digital pathology trailblazer. There are definitely things that I'm going to be quoting from this episode. For example, real research that ends up in a product. And I also have learned a lot about AI development and AI concepts from this episode. But if you're just starting your AI journey and how AI is applied in pathology, there's a video I recorded that explains this in a little bit higher level. That is a good video to watch in addition to this one. So go ahead, check the AI in pathology video, and I talk to you in the next episode.